Hey everyone, and welcome. So every single day, we're sending messages, we're streaming shows, we're hopping on video calls, all without giving it a second thought, right? It just feels instant, like it's some kind of magic. But behind that magic is one of the most incredible, complex, yet invisible structures humanity has ever built, the internet. And today, we're going to pull back the curtain and see how it actually works. I mean, just stop and think about that for a second. You can type out a message on your phone here, and it can land on a friend's device on a completely different continent in, what, less than a second? How on earth is that even possible? How do billions of totally different devices, we're talking computers, phones, servers, you name it, all speak the same language so perfectly? Well, that's the big question we're going to tackle today. Okay, so to get our heads around the massive, sprawling internet, we first have to zoom in on its most basic building block, the network. And honestly, the best way to picture a network is to think of it like a giant digital city. It's got its own roads, its own traffic rules, and yeah, even its own super efficient postal service. So at its very core, a network is just two or more devices that are connected so they can talk to each other and share stuff. In our digital city analogy, think of your computer, your phone, and your smart TV as individual buildings, like houses or offices. When you connect them all together, they form a little neighborhood, and suddenly they can all communicate. Now, as you know, not all cities are built the same way, right? Some have these old, winding roads, and others are laid out in a perfect grid. Well, it's the exact same for networks. This layout, this blueprint, is called its topology, and it's what determines the precise path that our data takes as it travels from one building to another. The way we design networks has really evolved over time, with each new blueprint basically solving a problem from the last one. I mean, it started with the super simple point-to-point, just a single wire between two devices. Then we got the bus topology, which was kind of like one main road that everyone had to share. But you can probably guess the problem. If that one main road got jammed, traffic stopped for everybody. So, of course, we had to come up with better, smarter layouts. And that brings us to the star topology. This is almost certainly the layout you've got in your own home. All of your devices, your laptop, your phone, that game console, they all connect to one central hub, which is your Wi-Fi router. It's kind of like all the houses on a cul-de-sac connecting to the roundabout in the middle. The only catch? Well, if that central router fails, the whole neighborhood is cut off from the rest of the world. Now, on the complete opposite end of the spectrum, you've got the mesh topology. Think of this as the super connected downtown core of our digital city, where every single building is connected to every other building by tons of different roads. If one path gets blocked by traffic, no big deal. The data just takes one of the dozens of other routes. This makes it incredibly reliable. Rock solid, really, which is why it's perfect for things like data centers where failure is not an option. The downside? Well, paving all those extra connections is, you guessed it, really complex and really expensive. So, we've got our city layout. Our roads are all planned out. But how does the data actually move? For that, we need some traffic cops and a postal service to manage the constant flow of information. In the world of networking, that crucial job belongs to a few key pieces of hardware.
Let's start with two really important ones, the hub and the switch. A hub is, well, it's pretty dumb. When it gets a piece of data, it just shouts it out to every single device that's plugged into it, whether they need it or not. A switch, on the other hand, is smart. It knows exactly which device the data is for and sends it directly there and only there. The difference is huge. A hub is like shouting a message in a crowded room, while a switch is like quietly passing a sealed, addressed letter to the right person. It's just way more efficient and a whole lot more secure.
Of course, our modern network has even more specialized workers on the job. The router is the big one. You can think of it as the main regional post office. It's the device that connects your entire local network, your little neighborhood, to the massive global internet. An access point is like a wireless on-ramp, letting your phone or laptop join the wired network highway without needing a cable. And a repeater? It's basically a signal booster, taking a Wi-Fi signal that's getting weak and rebroadcasting it so it can travel farther. It makes sure your message doesn't fade out before it gets where it's going. Okay, so we've got the roads and we've got our postal workers, but for any of this to actually work, every single house in our entire global city has to have a unique, one-of-a-kind address. In networking, every device gets one of these unique addresses, thanks to something called the Internet Protocol, or IP. Now, the original addressing system, which was called IPv4, had about 4 billion unique addresses. Back in the 80s, that sounded like a ton, but with the explosion of smartphones and smartwatches and even smart fridges, we basically ran out of space. It was like a giant apartment building that was completely full with no more vacancies. The solution was a brand new system, IPv6. It is so massive, it provides a virtually limitless number of addresses. We're not just building a new apartment block here, we are building an endlessly expandable new city for all our future devices. But wait, we don't memorize long strings of numbers to get to our favorite websites, do we? Nope. We use names, like google.com. So how does that work? This is where the domain name system, or DNS, becomes the hero. DNS is, quite simply, the Internet's phone book. When you type in a website name, your computer asks a DNS server to look up the matching IP address. The DNS server replies with that number, and your computer uses that number to connect directly. It's a beautifully simple system, and it all happens in a fraction of a second.
All right, this is it. Let's put this all together. We've talked about the city layout, the traffic hops, the addressing system. Now, let's follow a single email on its incredible journey through our massive digital city.
So check out how all these different pieces work together in perfect harmony. Your device is the office that writes the letter. The network topology, the star or mesh, is the road system it's going to travel on. Your local switch acts like a neighborhood mail carrier, passing the letter to the router, which is that big regional sorting hub that sends it out into the wider world. The IP address is the unique destination, written clearly on the envelope, an address you found using the DNS address book. And the internet itself? That's the whole global system of roads connecting all of these digital cities together. And that is how an email gets from your screen to another anywhere in the world in the blink of an eye.
It's pretty amazing when you think about it. The internet has evolved from these simple one-to-one connections into this vast, interconnected web that literally powers our modern lives. We've built this incredible digital world on top of these fundamental principles. And now that we understand the blueprint, it really makes you wonder, what's next? What's going to be the next revolutionary design that changes how our entire world connects?